Hey, this is Dr. B, and congratulations. If you've gotten to this point, it means that you've gone through everything you need to understand kinetics of a reaction on an AP chemistry, meaning a college level. So, way to go. Let's take a quick look at what we started with and see if you actually are nodding your head and saying, oh yeah, I remember that. So hopefully you're comfortable with the idea of reaction rate being measured many different ways: an average rate, an instantaneous rate, an integrated rate, um, and an initial rate. And hopefully you're comfortable with the idea that the rate of a reaction depends on which reactant you're talking about. If the stoichiometry is 1 to 2, well, that one with the 2 in front of it will always be processing twice as fast as the other one. So it's not such a simple thing to just say, hey, what's the rate of the reaction? You should have solved all sorts of problems on rate law where you get data that shows how a reaction is behaving with respect to each reactant. Is it a zeroth, a first, or a second order? No effect, proportional rate effect, or an exponential effect. You should be comfortable with the idea that the activation energy can be obtained if you have a rate constant and a couple of different temperatures. Generally speaking, AP Chemistry just wants you to be comfortable with the idea of it and how you could look into it. But we went ahead and showed you how you can solve a couple problems completely for that. We showed you that there's a general rule that comes out of that says that every time you increase the temperature 10 degrees, it should double the rate of the reaction. So great. I hope you're nodding your head and saying, yeah, I'm comfortable with all that. I solved all those problems, so I'm good. Now, typically at this point, most teachers go from kinetics to equilibrium. And for that, there's something you really need to keep in mind, and that is that for determining the rate of a chemical reaction, it's going to equal to some constant times the concentration of the reactants raised to an exponent. That exponent will be experimentally determined, number one. And number two, notice that the products have nothing to do with that. They spit out as a result of how fast the reaction is going, but we don't express them in the rate equation. They don't show up. Once we start doing equilibrium, it's a completely different thing. In this case, the equilibrium constant, not the rate constant, is going to be equal to the concentrations of the products over the reactants, where the coefficients do become the exponents. And it's not experimentally determined. You can write it out right in the beginning for a given chemical reaction. That rate constant, the equilibrium constant K does require some data input to come up with it, but you can set the whole thing up where those coefficients become exponents. Students usually trip up over that, so be aware that there's going to be a fundamental difference there. Okay, well, I hope you enjoyed the kinetics unit, and for this class, we're going to proceed forward now with the equilibrium unit.